Hi guys, I'm going to be walking you through how to solve two-step equations today. This is going to be on page 16 in your notebook. You fold up your paper like a booklet. Before we get started, let's talk about what two-step equations look like to us. Instead of what we did yesterday where we had one-step equations, two-step equations take 2 steps to solve them. So they might look like this: 6x minus 3 equals 9. That's a two-step equation because there's 2 things happening to x. There's a 6 and there's a minus 3, right? It could also look like this. This would be a really hard one to do. But we could certainly do it. It could look like this. And remember, fractions are just division, right? So anything that has 2 things going on with the x is going to be considered a two-step equation because it's going to take 2 steps for us to solve. Why would we need this? We would need to solve equations that we use to represent real world problems. We're actually in one of our upcoming units, we're going to get more into some real world applications of solving equations. Now, remember, for today and this whole unit, really, it's all about the process. It's not necessarily about what the answer is, but it's definitely about how I'm getting to the answer. Something weird just happened. Hold on, guys. Let's do. All right, hold tight with me. That's not it. My camera got lost. All right, hold tight. Let's see if I can find my camera now. Technology. There it is. Okay. All right. So guys, here's the step-by-step directions for how to solve a two-step equation. Remember, the goal is to isolate that variable, get it all by itself on one side of the equal sign. All right. So the first thing you want to do is you want to circle all the terms on both sides of the equal sign. Actually, I don't even know that you want to necessarily circle all your terms. Well, yeah, that's probably a good idea. Okay, circle all your terms on both sides of the equal sign. Then you're going to draw the river or the railroad tracks is what I called them yesterday, down the equal sign. Remember, whatever we do to one side, we got to do to the other, okay? We're going to undo everything using inverse operations. We're going to undo the order of operations. So if we think about our order of operations, it is parentheses, exponents, multiplication, division, addition, and subtraction. So if we're undoing that, we're actually going to work backwards. So we're going to start with our addition and subtraction. Then we're going to move to multiplication, division, and then exponents, and then parentheses if we had to. So using inverse operations, we're going to remove the constant, which is the regular number that's not attached to our variable, using either that adding or subtracting. So we're always going to do adding or subtracting first. Remember the golden rule: whatever you do to one side, we also must do to the other side. Okay, so whatever we add, we're going to add it to both sides, or whether we subtract, we're going to do the same thing. Now, the second step is doing the same thing. We're going to still use our inverse operations. Remember, that's our learning target, using an inverse operations. We're now going to remove the coefficient. using either multiplication or division. So we're working our way up that order of operations. Lastly, we're going to use the verify to determine if the value of X is correct, where we plug it into the equation. Okay, let's do some examples together. So our first example says 9x, gosh, that's terrible to read. 9x minus 7 equals 20. Okay, so we want to, first, let's talk about what's going on there. So we have a couple different terms. So we have a 9x, we have a minus 7, and then we have our 20. And then we're going to draw our line down our equal sign. Okay. Remember over on the left, it said the first thing we want to do is that addition or subtraction. So what I see happening to my X, I know I need to get rid of that 9 and I need to get rid of that minus 7. What's the opposite of minus 7? It would be to add 7 to both sides. That would leave us with, because this minus 7 and plus 7 would go to 0, which is our additive inverse, or sorry, our additive identity, we would just be left with 9x on the left, and then 20 plus 7 is 27. Now, remember what we talked about yesterday, 9x really is saying 9 times x. So the inverse operation to that would be to divide by 9. And whatever we do to one side, we also have to do to the other. So we end up getting x on the left. 27 divided by 9 is 3. There's my solution. I can verify my answer by plugging in 3 to where x is in my original equation. So I have 9. Instead of x, I'm going to plug in 3 minus 7 equals 20. So I have 27. Oops, sorry, not plus. Minus 7. Is that equal to 20? It is. So I know that I got my solution correct. All right. Our second equation looks a little bit scarier. Bigger numbers, and we have a fraction in there. Fractions are still just division, guys, so don't get panicked about that. So here's our 3 terms. Here's my equal sign, so I'm going to draw my line down. Remember, we always want to do our adding or subtracting first. So I see plus 32 on the side with the x. I want to get rid of that, so I'm going to subtract 32 from both sides. That leaves me with x over 5 on the left equals, what would that be? 53. No, what's 55 minus 32? If I subtracted 30, that would be 25. So 23, is that correct? I think so. Okay. All right. Now, guys, remember, what is this saying about x? It's saying it's being divided by 5. The inverse of dividing by 5 is to multiply by 5. That leaves me now with just x over here. 23 times 5 is, ooh, that's a tough one, 115. All right, then we just have to do our verify. Plug in where x is, we're going to plug in what our answer is, 115 divided by 5 plus 32. We're trying to see, is that in fact equal to 55? Well, 155 divided by 5 is 23. And now I got to add 23 and 32. That's 55. And it is in fact equal to the other side, which was 55. So I know I have my answer correct. All right, guys, I want you to try to do the next 2 on your own. So pause the video and then we can, and then press play when you're ready to check your answers. I think that's going to be the best way to do this, okay? Don't cheat. All right, here's my 3 terms. There's my equal sign. I'm going to subtract 76 from both sides. I get 4x equals, what would that be, 412. divide by 4, you get x is equal to 3. Oh, sorry, I'm off the camera there. There we go. So for verify, we have 4 times 3 plus 76 equals 88. So we're looking at 12 plus 76. Is that equal to 88? It sure is. All right, this one term, 2 terms. Here we go. Add 9 to both sides. We always want to start with our adding and subtracting, remember. X over 7 equals 21. Now this is saying x divided by 7. So the inverse of that would be to multiply by 7, not divide. All right, that leaves us with x equals 7 times 20 would be 140. So 147 is what I got for that one. If I verify, I have 147 divided by 7 minus 9 equals 12. 147 divided by 7 is 21. 21 minus 9. Ooh. 21 minus 9 would be 12. All right. Okay, guys, so you're going to do your practice, get it checked off by me in order to move on to your next step.